Today is the 10th. That's a great thing to start with. Great. What a pointless thing to begin. Hit record. Today is the 10th. Because that's what you need to know for. All right. You guys are going to be like, oh, it's the 10th. Oh, no, 14th. Darn it. All right. So, here we go. What was the first thing we did?
Forces. Fermi problems.
Fermi problems is the very first thing we did.
Wait, what?
Very first day of school. Whoa, that's not how you spell problems.
You have problems.
No kidding.
Hello.
I've got about 12 of them right now. It's funny because, I said that on Alright, what was the deal with Fermi problems?
Didn't you try to figure out
How many piano tuners are?
Oh my god.
Yeah, so the canonical example of this. How many piano tuners?
Wait, can we talk about what the Fermi problem is? Yeah.
That's what we're talking
How
about.
many Starbursts are in a bottle?
Oh, right. Those pieces. Did you go in order, or did you start randomly? Say, you did, the first problem was circuits, the second problem was Fermi problems, the third problem was mirrors, the fourth problem.
They're the order that I told you they were in.
Yes,
Did you? Were you not here that day?
Yeah.
Where I said every problem that was on the exam? Did you not get the email from the people who took notes that day?
No, I didn't hear that.
I said every problem that was on the exam.
No, you didn't.
Are we going to get you the trouble?
Did you do that?
So, alright, guys, a reminder. This is what I said was on the exam. This is probably a good thing to put on YouTube, actually. Here's what is on the exam. The short version. The first question is on optics. You will have a choice of a mirror problem or a lens problem. One of them. Do not do both. It will waste your time. Correct. Second question is on circuits. Third question is on unit conversions. Those are the three questions that are like numerical problems that you have to work through.
I'm really sorry, Mr. Rauhala. I couldn't find a pencil.
No, I've already said this. I put it on YouTube. We've got 2 periods to do the entire year. I am not repeating.
First, optics, lenses or mirrors.
But apparently
Second,
Rachel will.
circuits. Third, unit conversion. Okay.
Those 3 problems are the only ones that are going to have numerical elements that you have to do problems for. They're like the first problem on the last test.
So you have to draw them. You'll have to.
Yeah, they're
draw
like the first problem on the last test.
Okay.
That level of work.
Okay.
Next up is a question on forces. It's only dealing with asking if forces are balanced or unbalanced for situations and drawing free body diagrams. So the first forces worksheet we did, Newton's first law kind of stuff. All right. Free body diagrams. Fifth problem, energy. Basically asking big ideas like what is the first law of thermodynamics? What are types of energies that we dealt with? Not doing energy problems, not doing LOL diagrams, none of this 1/2 mv squared stuff.
Really? You're not going to do LOL?
So listens to anything I say.
So is
Classic.
energy, so is it
Or no
more
one remembers anything I
concepts
say.
than actual problems?
Correct. That is literally what I just said.
So we need to know, did we just did first law, right? Second, second law.
Correct.
Okay. I was freaking out, I was like,
We did not do the 0th, 2nd, or 3rd law of thermodynamics.
Okay, so.
Maybe I don't want to put this on YouTube. It's just going to be going like this for an hour and a half.
Thank you.
Maybe somebody will superimpose Kirk's head over my face going like this.
We definitely need to go over ours.
Evidently you don't there.
Alright,
You guys. So what's the 6th problem?
6th problem is relativity. There are 4 questions under this problem. You have to pick 2 of them. The first 2 are in special relativity. You pick 1. Next 2 are in general relativity. You pick 1. They are, again, kind of high concept problems. Not derive the time dilation factor for a muon going at
General.
yeah, high concept. 7th and last problem is the kind of random topics problem. There are 10 questions there. You have to pick 3 of them. They range.
Sorry. You said just random questions? That's not random, but random from.
They are based on kind of the demos, labs, and kind of the weird end of topic days that we had throughout the entire year.
Labs.
So there might be one of the waves or something like that.
So there might be one on light, there might be one on Fermi problems, there might be one on like the step structure of the atom. The last one I will tell you straight up is just pick something that hasn't already come up on this test and tell me about it. That is literally what the question, well not literally, but that is basically,
Why are you
if the Doppler effect is not already on the test, yes.
What about that thing where it's like when you're on a roller coaster?
Alright, I'm not going to go through and tell you what all 10 of them are. That defeats the purpose of it being, like a broad range of topics. You do not have to study like all of the material from the year. The idea is that hopefully you remember some of these things. Not because you went and memorized your 50 pages of notes. So the hope is that some of these things stuck with you. Failing that, there are enough from second semester that by studying your second semester material, you'd be able to get through it anyway.
Under the random, when you guys talking about the labs, like what about?
So just like some of the labs or like demos that we did might be like fodder for questions. So I might talk about like the day we put the plane up on the ceiling or playing with the Van de Graaff generator, stuff like that. So some of those might feed into a question if you remember what kind of like the moral of those stories were.
Okay.
All right.
Well, we have to use equations.
No, they're all just going to be like one sentence short answer things.
So for unit conversions, is it going to be like that the third one?
Yes.
Is that going to be like ABCD? Like, you know how one of the worksheets was like convert?
It's going to be, it'll be mostly, so you remember the problem on the circuits worksheet that had to deal with the current? It said if a current of this much was running for like 4 minutes, how much charge went by? It'll be like that kind of stuff. Mixed in with some kind of like dealing with SI prefixes. Yes.
Is it going to take a full 2 hours, do you think?
I don't know.
You have no idea.
I don't imagine that most people will leave early just because it's a test and you'll probably be panicked for the entire thing and feel like you have stuff you can always do.
No, yeah,
I
I know what
think-
you mean, but do you think we're going to have
I
like,
took
adequate
the
amount of
entire
time?
I took the entire test, doing every option. So like doing both of the problems on optics, doing all 10 of the the last choices, doing all of the relativity questions, like doing every optional part. It took me 22 minutes.
So we're supposed to do 3 times that. So that's what's take us 60. Roughly. Not counting that.
So it should take you less than that because I did more tests than you will have to do.
So,
22 minutes. It's a lot of writing. They're sentences.
We have 2 hours.
That's
2
little.
hours to take.
So it's not going to, it's going to take us probably like a period of time.
Yes.
Technically, but-
So, and if we're, like for motion, we're not know it.
So was that one of the things I just said?
We talk about Fermi problems.
Okay. So go on, Heather.
I have one question. Unit conversions, will we have to remember like what each of the different prefixes are?
No. Consistent with all the stuff we've done so far, if I give you an SI prefix, I will tell you what it means. So I will tell you that, kilo is 10 to the third, milli is 10 to the minus third, mega is 10 to the sixth, nano is 10 to the negative ninth. You're responsible for being able to deal with exponential notation. Like, you got to be able to deal with powers of 10.
Are we allowed calculators?
Have I banned you? Have I banned these of
sorry.
calculators? Why do you think I'm suddenly going to turn into like a super ogre? I've just been a regular ogre all year. Like, just because the final exam is bigger. Oh, do we want to like actually review material?
Yes.
How nice. Maybe next time people will like remember the stuff that we've already done. So the idea with this was we wanted to make these outrageous estimates. Like asking how many piano tuners in New York is a ridiculous question. But the idea is I might say, well, how many pianos do I think there are in New York? How often does a piano need to be tuned? Well, I know that maybe every third family in New York has a piano. It's a reasonable thing to have. New York's kind of a classy city. Maybe there are a couple million people in New York, so maybe half of them are in families, so maybe based on that, a third of that population has a piano. All right. How often does a piano have to be tuned? Let's say a piano has to be tuned once a year. How long does it take to tune a piano? Maybe it takes most of a day. So if I've got to tune, a couple 100,000 pianos every year, and it takes 1 day to tune a piano, how many people do I need in order to tune that many pianos every year? If they're working all day, every day. Well, because how many people then does it? So if I've got 200 working days in the year, right? And one piano tuner can tune 1 piano in a day versus 2 pianos in a day. That tells me how many tuners I need. Yeah. The person is can each tune. How many pianos can each person tune? Yeah. Yeah. So I said maybe once a year. But the idea is that we can kind of work around all these little factors to come up with an estimate. It may or may not reflect reality, much as our projects may or may not reflect reality, but we can at least chip away at it. Remember, the example that we did is how much time does the average Ella student spend studying? Looking back on that, we might all get a good laugh at the results, but because we were so happy a year ago. But that was basically what we did, right? We said, all right, so maybe the freshman spends this much time per class, the junior spends this much time per class, the senior doesn't spend any time per class, the freshman has this many, the sophomore has that many, and we got to a number at the end of the day, right? So that's the idea behind a Fermi problem. All right? Yes?
Yes.
All right, what was the next thing we did?
Forces.
Unit conversion.
Unit conversions was the next thing that came up. So, we've just had a lot of practice doing unit conversions. What unit conversion have we all been doing to death for the last couple of weeks?
Hours, seconds.
Hours to seconds to minutes to days to whatever, right? So let's say that I wanted to convert 3.5 days to seconds. How would I go about doing this? Yeah. So, what's the first step I can make?
3.5 over seconds.
So if I want to move from 3.5 days to some number of seconds, what's the next step from days? What's the next? So moving towards seconds, hours, right? So there are 24 hours per day. So I know I want days on bottom, hours on top. And I know this ratio is 24 hours to 1 day. Right? You can drag a chair right up to the front row.
Hours.
So what's the next step?
Minutes.
Hours to minutes. So I want to have hours on bottom, minutes on top. 60 minutes to 1 hour, right? All right. If you don't remember anything else from physics, this is the single most important thing to have learned this year. Because this is the only thing that you will use again and again and again without fail in all of your science courses for the rest of your natural lives. Your unnatural lives, presumably you will have a computer chip in your head that will do it for you.
Hey, does it reach the 15-minute mark?
No, we're at like 13 minutes. All right. Does anyone want to put this into a calculator and get me a number?
So what do you just times the top?
Yeah, so I just do
I got it.
3.5 times 24 over 1 times 60 over 1 times 60 over 1.
So just like 300.
Yeah. So all of these units cancel, right?
30,000.
300? Wait, what?
Yeah, 300. 400.
All right. We good?
Yes, next.
So one other note here. Remember, later on we started adding in kind of SI prefixes and doing stuff like that. What was the way to deal with the SI prefixes? What's the cheap way to do it? Moving the decimal, right? The power of 10 tells you how many times you have to move the decimal, and you have to figure out, do I need a bigger number or a smaller number? So let's say I have 1 gram. If I want to go to kilograms, do I need a bigger number or a smaller number? Smaller. 1 gram is less than 1 kilogram. So the decimal place, if I got 1, has to move to the left. Well, kilo is what? 1,000. 1,000 has 3 zeros, 3 powers of 10. Now, if I got 1 gram, I want to move to milligrams. Is 1 gram bigger or smaller than 1 milligram? 1 gram bigger or smaller than 1 milligram? Bigger. So if I got 1 gram, I got a lot of milligrams. So the decimal place moves to the right. And milli is how many? 1,000th. So again, 3. So 3 bumps to the right. All right? We good? All right, that's the 15-minute mark. Actually, on the nose.